Back in June, Anton Kapela and I had a conversation on my second YouTube channel called DGR Unicast about HTTP3, QUIC, AI, and efficient network design, among many other topics. And one of the things that we started getting into later in the video was using the QUIC protocol to combine multiple network links across different media types, including unicast and broadcast. Now, if you don't know what QUIC is a modern, secure protocol built on UDP that combines the reliability of TCP with faster connection setup, built-in encryption, and support for multiplexing and mobility. In fact, every single website that I make uses QUIC. So there's a good chance if your browser supports QUIC that you are loading the WNY over the air website and all of my other websites that my company manages using UDP connections. Now, a lot of this gets very technical very fast, so I just want to make sure everybody is on the same page. You'll hear the word media thrown around. In networking, media means the physical or wireless pathways like coaxial cables, fiber cables, or radio waves that actually carry data signals. So not media in terms of like physical media like movies and TV shows, but media in networking and in the OSI model is layer one. It is different pathways that data can be sent. In this case, we are talking about broadcast like ATSC 3.0 or 5G broadcast and your Wi-Fi connection as two different media. Now, I've done multiple discussions with Anton because he is a very smart individual, and what we're talking about, in my opinion, I see as the future of communications. So without any further ado, let's get into this segment talking about the convergence of different media types using QUIC.
It's also useful if we can combine multiple network links in a meaningful way. It's unlikely right now. We haven't seen a lot of examples of this where QUIC can subvert the host's routing table and force some packets to go out link A and a different flow or a different stream out link B. But if that becomes available to user-land applications, then game on. That's actually a super interesting, advantageous direction that applications themselves could now engage, meaning they can be dual linked or multiply linked into an underlying backend resource. And that could be across diverse media or, ta-da, different kinds of media. So maybe a broadcast link, like over the air, can exist to suffice for or to provide for some sort of common delivery content, say video or audio in progress for a live event. And the two-way channel could live over Wi-Fi or cell or whatever else. And the application layer can figure out what's the best way to get that data in or request it, given all sorts of conditions that maybe the OS doesn't want to probe for or support. Because again, this is kind of supporting the app or the developer and the content person's interests, not Apple Inc. or Microsoft Inc. per se, right? They want to make a generic OS for their commercial interests, not for TikTok or Twitch or whatever else. So it seems reasonable on the surface to say, hey, if we have a standard way to do this with UDP and combine or straddle, if you will, multiple different types of network media, i.e., some that are not bidirectional, that are not two-way, some that are one-way, some that are maybe coupled with two-way request paths over the internet or whatever else that can influence the downlink delivery on a broadcast path or something like that. Now we got some interesting stuff. Now maybe, in my personal opinion, it crosses my interest line for what would be QUIC friendly stuff to do, because now it's solving a real problem that we're not addressing any other way. So in that case, though, we could do things like a broadcast delivery, maybe a 1 megabit base layer with some, low resolution or medium resolution 480, 720 kind of stuff with versatile video codec, and then have variable refinement layers on a two-way network or other one-way networks that are optionally usable by the decoder. So this
using
sort
a
of
technology
thing,
like layer division multiplexing and all of
well,
those.
yeah, exactly. So let's say you're actually doing LDM on broadcast, and some station says, "Hey, that's what we're going to do. We're only going to do base layers on our broadcast pipe, our pilot signal, right?" And they don't do anything really high speed on top of that. So maybe someone says, "Turn all the knobs down, make this work in negative 10 dB SNR." And now I get like maybe sub megabit, in a 6 megahertz wide channel. Okay, but I could bond several of them. So now I got 4 by, LDM channels or whatever, maybe not division, but maybe just base, real low level coding, 1/2 rate or less at QPSK or BPSK. Great, that's going to work down in the weeds, like well below noise, unity noise, signal to noise ratios. And so this is super robust now, and maybe I can have enhancement and refinement layers on a two-way network somewhere
Just about to
alongside.
bring that up. Yep.
Yeah.
Yeah,
So
you could
so
totally, you were talking about extremely robust, lower layer
yep.
ATSC 3 or, 5G, LTE based multicast, tech whatever
Right.
transmission broadcast method, and being able to have maybe a 720p copy of that being the base layer that's broadcast to everybody. And then if you want that 4K copy, I know VVC has scalable video built into the codec. That could be, with code, you could do so many cool things to bridge broadcast and unicast.
Exactly. And then even more interestingly along those lines, like what we haven't done for a long time now is implement or integrate multicast on a local network for bulk delivery of any sort.
Oh yeah,
Uh,
I'm actually thinking of that when I use the HD home runs, and
right.
I'm thinking, geez, this thing is being broadcast for 17 miles from my house in the air, and everybody else is getting it. But as soon as it goes on my local network, it's like back to using up a lot of power again, back to, inefficient. And, why not? I know when I tune into an HD home run, I'm using one of the tuners for a unicast, transmission over the local network, and I can't, you know, have everybody in the house use that one tuner at the same time if I wanted to.
So the thing that's interesting about the box though is that it can do, directed multicast to the wire, but you have to use the UDP API. But here's where
Yeah,
it's cool. Because the way that they can structure this thing, the way that they structured their UDP, UPnP API, is that an endpoint on a phone or a set-top box can tell it, hey, use tuner zero or pick a tuner automatically, pull this program in and send it to this multicast group of address
yeah.
X. And that can then flood the local network and be joined by anything that wants to use that multicast group or receive it. It's kind of kludgy in the case of Wi-Fi, and you can look at the directory, rather the trajectory of where this stuff came from and where it's at today, and you can clearly see that there's a kind of a transition where it's becoming obvious and clearer to more and more folks developing home applications, home boxes like this, that you can't expect multicast to work reliably on Wi-Fi. So now it
Yeah.
becomes put it over TCP or IP unicast to get around those issues because just there's no acknowledgement mechanism, there's no retransmissions, loss is loss, and MPEG-2 looks pretty bad when you start to have a lot of that stuff. So, I can see the rationale. I get why they did what they did, and they still support both. In the way that we're talking about it here, if QUIC drove the whole thing, and if QUIC could gain some additional protocol support or the apps implemented it, finding tuner resources and reserving capacity on those, one of four tuner slots, and or saying, hey, bring this thing to a multicast group that two or more devices are going to share or use, makes a lot more sense now if it's mostly reliable delivery. And we do have some loss potential, but a two-way channel will make it up and some scalable stuff on top or on the wayside. That might look like taking the unicast delivery problem from n streams over a content delivery network in a dense metro to like 20% retransmission rates
Yeah.
for the same n million streams, and the primary amount of it or the majority of it comes over broadcast. We don't have a mechanism to like make the app layer and the codec layer do the right stuff right now. QUIC might be one way into that, like a maybe oblique kind of way, but that's maybe a stretch right now. But I still
Well, I
feel
mean, if you
comfortable
think
about it.
about it, both the broadcast or multicast and the unicast would all just be UDP. So at a very foundational level, you're just UDP across the board, and then you're developing the smarts on top of that. I mean, that kind of simplifies some things.
It does, but it means that like app programmers have to kind of, I don't know, determine, coordinate with broadcasters in particular, the people that own that resource,
Yeah.
in a way that structurally looks like an easy place to kind of pick up these feeds and kind of organize and detect that presence. So what we don't have today, hinting at some of the work that I'm consulting on, what we don't have today is a mailboxing concept for broadcast resources.
No.
We have a USPS everywhere delivering stuff to my postal box and for yours as well, but we don't have a way to have them drop off things for a neighborhood or a
Yeah.
city. We have bulk mailers, but they still get tossed in every single person's box. What I want is like that big parking lot, empty over or whatever, available full of stuff to me to grab and pick up when I want it.